Okay, so today we're going to be doing algebra, we'll be doing 9.2 graphing rational functions. Hopefully you'll be able to see this, but you do have your worksheet in front of you. So everybody should have the worksheet out right now. And we're going to start by looking at a parent function that you do know something about, y equals the square root of x. And when we learned about it in class, I told you clearly that it looked like something like a half of a parabola turned sideways. And we talked about what points that I always wanted you to use on the graph. Those x points I wanted you to use were 0, 1, 4, and 9. And if we plugged those x's into the graph, what would come out would be 0, 1, 2, and 3. I picked those points because they're nice, perfect squares. We also learned about the domain of this graph. We never want a negative inside that radical, so we always want this to start at the number 0. So our domain would be x is greater than or equal to 0. The range, I always told you to look at the graph and look at the y values on the graph. So in this particular instance, the y values start at 0 and they're going to hit every y value going all the way up forever. So y's greater than or equal to 0. We've also, over the course of class, learned a lot about taking that parent function and changing it based on adding some numbers to the graph. So for example, if I look at y equals x minus 1, that's inside the function, and I always said ixoid. Inside affects x, outside affects y. So my rule on this one, y equals the square root of x minus 1, my rule would be x plus 1 y. It changes sign when it's inside, it doesn't change sign when it's outside. For y equals the square root of x plus 1, my rule would be x, y plus 1. Again, the y went up plus 1 because y's don't change. Y equals negative x square root of x means I'm flipping it over the x-axis, but it's on the outside, so it affects y, so x, negative y. And then the last one, y equals square root of x plus 2 plus 1. Inside x, outside y, so x, change the sign, so x minus 2, y plus 1. All right, let's graph this last one. Y equals square root of x plus 2 plus 1. And if you remember from when we learned about graphing, I said the first thing you should do is write down the parent function. So my parent is y equals the square root of x. Then pick the points that we always want to graph on that function, 0, 1, 4, and 9, and get the coordinating y's, which would be 0, 1, 2, and 3. Look at your new function, write your rule, which we already did, and our rule was x minus 2, y plus 1. Apply that rule to the parent function, so that means all of your x's you're going to subtract 2, and all of your y's you're going to add 1. So our new coordinate points would be negative 2, negative 1, 2, and 7. And our new y's would be 1, 2, 3, and 4. We go to our graph and we plot those points. Negative 2, 1. Negative 1, 2. 2, 3, and 7, which is not on this graph, so 5, 6, 7. We'll just estimate right about there. And then we make our graph so it looks just like our square root graph. Our domain and our range has changed. Our domain is all of our x values, and if we want this to stay either 0 or positive, so our domain would be x is greater than or equal to negative 2. My range has changed as well, but we look at our graph. The y values start at the y value of 1 and go up forever, so y is greater than or equal to 1. Okay, so we're going to move on to rational functions. So now we're going to graph a new parent function. We're going to add this to our repertoire of graphs. So we're going to graph y equals 1 over x by filling in the chart that I gave you for with 1 over x. It says do this with your neighbor, but we're doing it at home. So I want you to plug in -4, -3, -2, -1, -1/2, 0, 1/2, 1, 2, 3, and 4 into that function. I also want you to kind of notice, it looks like an inverse variation that we talked about. It looks like y equals k over x. My k in this case is just 1. I'm going to rewrite it right here. So we have y equals 1 over x. We plug in -4, we get -1/4. We plug in -3, we're going to get -1/3. -2, we're going to get -1/2. And if we plug in -1, we're going to get -1. Now if we plug in -1/2, we now have 1 all over -1/2. So we have a fraction in the denominator, so we change it to multiplication, and we take the reciprocal of the denominator. So we're actually going to get -2. We can't put 0 into the denominator. It's undefined there. Plug in 1/2, we're going to get 2. We plug in 1, we'll get 1, 1/2, 1/3, and 1/4. Now the interesting thing is, it's undefined at 0. Means we can't put 0 in there, it's going to be undefined. So that means at 0, we are going to have we're actually going to have an asymptote, okay? So we're going to put in our asymptote, a vertical asymptote, y equals 0. But interestingly enough, if we can't put 0 in here, that means that we also can't get y to ever equal 0. So there's another asymptote. We have a new asymptote. It's called a horizontal asymptote, and it's going through the points 0 as well, but it's y equals 0. So we have a horizontal asymptote, y equals 0. We have a vertical asymptote, x equals 0. This graph's going to look really different than what you're used to. So we're going to plot our points, and we're just going to be around. So 4, -1/4, 3, -4, -1/4, -3, -1/3, -2, -1/2, -1, -1. All right, -1/2, -2, right about there. Do you notice anything? If I am to plot these, they're going to get really, really close to those asymptotes. But remember, an asymptote is a line that we can get really close to, but we never touch. I go to the other side, and I plot 1/2, 2, 1, 1, 2, 1/2, 3, 1/3, and 4, 1/4. We have a very similar graph on the other sides of the asymptote that looks like that. So we're going to have to get used to this graph. It looks kind of different than what we're used to. All right, so what's this graph called? It's got a name. This graph's called a hyperbola. The two parts that you see there, the left and this right part, are called the branches. I also want you to notice that there's no y-intercept. So there's no ordered pair with x equals 0 because we can't put in 0. Or the denominator would be undefined. Therefore, x equals 0 is not in the domain. And I want you to remember that. I'm going to bring that up a lot. So the domain on this function is x equals 0. And I mentioned that a few seconds ago. Also, notice there's no x-intercept. There's no ordered pair with y equals 0. So therefore, y equals 0 is not in the range, and our range is y cannot equal 0. All right, but there's some important things that you need to know. A fraction is undefined when its denominator is 0. We've talked and talked and talked about it. So for these values of x, you're going to have a vertical asymptote. You're going to have a vertical asymptote. In the parent function, this is at x equals 0, so x equals 0 is your vertical asymptote. Okay, the horizontal asymptote in the parent function is y equals 0. This is because when x gets large, y gets very small, but it's never actually going to get to the number 0. And another important fact, we're going to always use the points 1 and negative 1 for x and solve for the parent. We're going to use them, we're going to call them kind of like anchor points for our parent graph. Let's look at first at a few examples, and let's see if you guys can actually see a pattern to everything that we're doing. Okay, so we've already done this parent function, okay? Our parent function, y equals 1 over x. All right, the points that we picked on the parent we already did, but for us, for our future points, we're going to use negative 1 for x and 1. We plug those in, we'll get negative 1 and 1. Obviously, since it's the parent, it doesn't have a rule. We can't apply our rule to the points. What we can look at, though, is our vertical and our horizontal asymptotes. It has a vertical asymptote at x equals 0 and a horizontal asymptote at y equals 0. Okay. So now let's look at how we're going to use this to translate graphs. Y equals 1 over x minus 2. First thing you need to know is that inside of the graph will always be in the denominator, that means inside. And outside would be outside the fraction. Okay, so inside, outside. You also need to know that this number over x is always going to be your parent. So in this case, my parent's y equals 1 over x. The points that we plug in, always on the parent function, negative 1, we would get negative 1, 1, and 1. Okay, what would our rule be? Well, inside x, outside y, so my rule here would be x plus 2, y. The difference now is that we're going to apply the rule to the points and to the asymptotes. So we apply the rule to those points, so we're going to add 2 to all my x's and we're going to keep our y's. So we're going to add 2, negative 1 plus 2 gives me 1, 1 plus 2 gives me 3. All right, but now we apply the rule to our asymptotes. And remember, our rule was x plus 2y. So that means for our x equals 0, we're going to add 2 to it. So x equals 2. Our y, we're going to leave it alone, so it's y equals 0. Now, let's graph that, okay? So why don't we get, you guys, I gave you a place that you could do that. But I'm going to do a quick sketch. So the first thing you always want to do is you want to go ahead and you want to put in your asymptotes. That's very important. So I'm going to go ahead and put in my asymptote at x equals 2. It's a vertical line. It should be dotted. I would highly recommend you do it in a different color. Then you want to put in your horizontal asymptote. Again, it's a dotted line. Let's remember, an asymptote is something that our graph can never touch. Okay, and then we plot our points. Our first point that we came up with was 1, x is 1, y is negative 1. So we're going to use that as an anchor, okay? I want you to put your anchor in. Now, if you think about our parent function, we have to realize this graph's going to get really, really close to the asymptotes, but it's never going to touch it. That's going to be, that anchor point's going to be kind of like where the graph turns. The other part of the graph, we look at our other points that we plotted, which were 3, 1, which is right here. So the second branch is going to start really, really high. It's going to turn at that anchor point. It's going to get really, really close to the asymptote, but it's never going to touch it. Okay? And that's how we graph these functions. I like to call it graphing by the asymptotes. All right, let's jump back. Let's see if we can do the next one. Y equals 1 over x plus 3. Our parent, y equals 1 over x. We've got our points, negative 1, negative 1, 1, 1. Our rule would be x minus 3y. We go down to apply our rule to our points. So it means we're going to subtract 3 from all of our x's. So negative 1 minus 3 gives me negative 4. 1 minus 3 gives me negative 2. My y's don't change. I apply my rule to my asymptotes. So it's telling me from x equals 0, I want to subtract 3, so now my asymptote is at x equals negative 3. Y don't change, so y equals 0. Now if at any point you guys feel like you need to back up, pause the video and just jump back. The last thing we're going to do is the hardest when I put both of them together. You go through the same process. You write your parent function, y equals 1 over x. You use your points that we're always going to use on that parent function, negative 1, 1, 1. You write your rule. And in this case, be really careful, but our rule is x plus 2, y plus 1. So now you got to change all your points. So you're going to apply your rule to all your points. So we're going to add 2 to all of them. Actually, let's just kind of go back so we can still see them. So we're going to add 2. So we're going to get 1 and 3. And then we add 1 to all our y's. So negative 1 plus 1 is 0, and 1 plus 1 is 2. We have to do the same thing, apply our rule to our asymptotes. So my asymptote is going to change to 2 and to 1. And let's go back and let's look at a graph of that. Okay. So I have an asymptote at the point, get these on there. So I have an asymptote at the point x equals 2. So I'm going to go ahead and put in my asymptote at x equals 2. I have an asymptote as well at y equals 1. Okay, again, do them in different colors. Let me jump back for a second. My points on my graph were 1, 0, and 3, 2. 1, 0, and 3, 2. Now remember, be really careful. You got to know what this graph looks like. It can never cross your asymptotes. Those are just anchor points. It's got to look like this. It's got to have both branches going through, looking like that. And you can always go to the y equals, and I want you to do this for these. Go to the y equals feature on your calculator, type in the function, and verify it with your calculator. Press graph and verify it. Hope that was helpful. We'll do lots of practice tomorrow in class. Thanks.